All right, so this is our first lesson. Evaluate each of the following logarithms without using a calculator. This says log base 3 of 81 equals to what? Basically, to understand logarithms, I'm gonna write this a little bigger because it's kind of small. It says log base 3 of 81. You want to find out what it's equal to. You essentially look at these two numbers, 3 and 81, and you want to decide how 3 can be raised to the power to get to 81. So you think about that. 80 is basically saying 3 to what power gives you 81. Is basically what this means with that logarithm. So you got to think about how can I rewrite 81 to be some power of 3? Well, 81 is really 9 times 9. So it's 9 to the second. So for that matter, 9 to the second is really 3 to the second to the second. So that means 81 could be 3 to the fourth. So 3 to the x equals 3 to the fourth. So I know the x has to be 4. So for this problem, I know it equals a 4. And that's how that logarithm works. The next one I want to do, I'm going to skip b for now because it has negative signs in it because I see that 1/2. I'm going to go to letter c. And we'll do b and d at the same time. So looking at letter c, that says log base 12 equals 144. And if I'm working with that one, so I'm basically thinking, if I gave you log base 12 is 144, I'm thinking 12 to what power gives me 144? So 12 to some unknown power is 144. Well, you might just know it's 2, because 12 to the second is 144. So I think that's pretty easy. X is just 2, because 144 is really 12 to the second power. So x has to be 2. All right, now look at the ones with negative exponents. Whenever you have fractions involved with logarithms, you're going to have negative exponents somehow, some way, or negative values. I should mention this too before I begin. You can not take the log of a negative. Cannot take the log of a negative number, ever. So log of negative 3 does not exist. All right. So can log be negative? Yes, you can have the output that's negative. You just can't take log of a negative number. And another thing I need to mention, so I don't forget, log of 0, always 1. Log of 0 is always 1. So those are the two rules that I want to make sure I mention because they appear so much. It's very easy to just assume you know. So I want to make sure I told you. All right, so look at the next part with the negative exponents. This says log base 4 to the 1/2. So log base 4 of 1/2. So basically saying 4 to some unknown power gives you 1/2. And truth be told, 4 is really 2 to the power. So I'm going to write 4 is 2 to the second to the x. And for that matter, 1/2 is really 2 to the negative 1. Whenever you have a fraction like this, it's a 1 here. So to bring it up, you change the sign on that 1 and make it negative. Again, this is a 1 as its exponent. So anyway, so 1/2 means 2 to the negative 1. So basically what we now know is, I'm going to rewrite all of this. 2 to 2 to the x means 2 to the 2x equals 2 to the negative 1. Hope you can follow that. I now know that 2x has to equal to negative 1. So I know if I divide by 2, I get x equals to negative 1 divided by 2. So this value is negative 1/2. And I'm going to show you how to check that with your calculator later, but that's how that works. The last one is letter D. And letter D is very similar. What you have is log base 6 or 1/36. So it's saying 6 to some unknown is 1/36. Well, 1/36, we should know that's 6 to the second. So I'll write it over here. So 6 to some unknown equals 1 over 6 to the second. And we just decided that when you have a variable on the bottom, you should call it 6 to the negative second. So you should now know that x must equal 2. But yet negative 2. So the answer here is negative 2. I think that was 2, and I think this was 4. That's how those work. All right. I think you know enough to begin. So I'm going to stop it there, and you can go to my first assignment for today.